All right, so today we're going to wrap up the pieces that I would say fall under primitive data types, just all the bits and pieces that help us understand how basic data types work within computer systems. And so I've labeled it arbitrarily as arithmetic. So some of those last pieces that I want you to understand, uh, and and the first of those is, I say, really very useful in incredible ways. So that is moduli and division. So depending on where you are in your course, you've used modulus before, but modulus is going to be a very close friend of yours, and that is it's basically what returns the remainder. And so if you have two integers, k being greater than 0, um, we write the modulus as n mod k in mathematics. And I'll show you an example of what that looks like in Java as well. But n mod k is the remainder we get when we divide n by k. So for instance, if I have the number 7 mod 5, that's the remainder I get when I divide 7 by 5. So I'm going to show you the fancy way of looking at that, but essentially if I divide 7 by 5, I can fit 1 5 into 7, and then I've got 2 left over. And so 7 mod 5 is 2. That's the way I think about it. Now, this can be formally defined by saying, well, that's the number itself, so 7, minus the number of times I can fit 5 into it, right? So in this case, I can fit 1 5 into 7. And the way that we figure out how many times I can fit the integer 5 into 7 is I take the floor of 7 over 5. And so it's the biggest integer that I can fit um, into 7 over 5, which makes sense. That's the number of times I can fit 5 into 7. I'm not going to break it down in the same way for this, but if we take 18 mod 7, that's the remainder when we divide 18 by 7. And so 18 divided by 7, I can fit 2 sevens into 18, right? 7 and then 14, that's 2 times 7. And what I have left over is 4. The way this is used might be come apparent 3 slides from now. Um, but essentially in Java, the way that we do that is we use this percentage sign. And what 7% 5 gives you is 7 mod 5. And if you haven't seen that yet in your class, this is just a look ahead. This is the math that you'll be playing with later if you're in 1105 and 1110. And the way that we actually use this a lot is to decide the parity of a number, decide if a number is even or odd. The other term that we use is to say something evenly divides another number. And so if we have two numbers, we say that k evenly divides a number n, and we denote it with this k slash n if n modulo k is 0. So that means there's no remainder if I divide n by k. So for instance, I can say that 5 divides 15, evenly divides 15, because 15 mod 5 is 0. Or another way of looking at that, if I take 15 divided by 5, I get an integer back. Okay? So the terminology might be new. Not everybody has seen modulus before, but the concept is from junior high, right? Or probably less. Division, remainder, these are old school concepts, but now we're using them in new ways. Likely up until this point, you really didn't use the remainder to any great advantage, aside from possibly considering even and odd. And when we think about numbers, that's where this modulo becomes really useful. And so likely you know the definition of even and odd, but we're going to describe it in a slightly different way. So if we have a non-negative integer n, we can say that it's even if n mod 2 is 0. It means when we divide by 2, there's no remainder. Before now, you've probably seen the definition that a number is even if it's some multiple of 2, right? If 2 evenly divides that number. So that's using both of the terms that we've just used. Um, The other way that we can, the way that we can look at odd is if we say it's 2 times some integer plus 1, right? That's the way that my 8-year-old that you met just before class started defines odd. It's an even number plus 1. Well, when you look at modulus, you can define that as n mod 2 is equal to 1. So this is a way to do a quick check if the number that we're working with is odd or even, and we can use that percent sign in Java to return that value. So I would say n percent 2 in that scenario. So another word that I have used is parity, and parity is it's an important piece. And the parity is, if I say, what is the parity of that number? I'm asking you, is it even or odd? So it's the evenness or the oddness of a number. So 7 is odd, and it has the opposite parity of 42, which is even. So in terms of making use of that in your programming, you can do all sorts of things. So I'm playing with a few different pieces here. I've given you a Boolean value, so that's something we discussed last class. So something that's going to be either true or false. And I've set up 2 different variables. One is even and the other is odd. And they're going to hold a true or a false value. And what happens here is if n percent 2 is equal to 0, then that's a condition that's true, right? If it's not, that condition would be false. And we're going to talk about true and false and play with Boolean values and logic a lot more later. So don't let this is not what you're taking away, but you're going to want to be able to play with this when you're in 1110. So what happens is even is going to be true every time n is even. Is odd is going to be true every time n is odd. Since you're mostly all taking 1105 and 1110, you can play with these bits of Java and get familiar with them. They're going to help you. Generally, I pick things that I would want to be able to use. And so if you wanted to do a parity check, the way that you could do that in Java is you can say, look, if n percent 2 is equal to 0, then it's even. Otherwise, it's odd. Okay, so now it's time to consider primes. And I mentioned that primes are super important, and I know you've seen this before, but just so that we all have the same definition, a number is prime, so a positive number greater than 0 is prime. Greater than 1, I apologize. So we don't even consider 1 when we talk about prime and composite numbers. And that's really important because people often add 1 to the list of composite and prime numbers and get confused by that. But a number is prime, you'll recall, if only the positive integers, if the only positive integers that evenly divide it are 1 and itself. Okay, so for instance, the number 2, 1 evenly divides 2, 1 divides all of those positive integers greater than 1, so we don't have to check that. But the only other number that evenly divides 2 is itself. The same is true for 3, right? 3 evenly divides 3, but 2 does not. And so we can keep checking. The first 10 primes in a list are listed for you, 2, 3, 5, 7, 11. The others are composite. And we can see an example of that. A composite number is just all those numbers that are not prime. So those numbers positive integers greater than 1 that are not prime. So there's another number that evenly divides it. You'll see if you look at the list of the first 10 primes, the first number missing is 4, and that's because 2 evenly divides 4. All of the evens then are immediately thrown out, right? Because 2 evenly divides every even number. But the first odd missing is 9. And so why is 9 missing? Answer in the chat. Yeah, 3 evenly divides 9. Exactly. And so an example of the 2 numbers we were looking at, 7 is prime, 42 is composite. And that's because 6 and 7 both divide 42.